Good day, everyone. Welcome back to day two of WFGN Global Interactive Summit 2026, the Ocean of Innovation. My name is Kode Swaminathan. I'm a marine biologist and PADI dive master. I did my master's in tropical marine biology at the University of Essex. Along the way, I have studied the coral stress responses in Indonesia, helped restore damaged reef, and worked as a zoological associate in SeaWorld Abu Dhabi. I work I currently work as an independent marine biology consultant and I've recently been selected for the KCRI project in Saudi Arabia. I am an IUCN certified Red List assessor, global and regional, and it's my pleasure to be hosting this session. I'm looking forward for today's conversation. Our session today is called Ecosystem is Talking and it's built around the aquatic environment management. Think about it this way. Every fishery, every fish farm, every coastal community depends on this one thing: healthy water. And that water is always talking to us. It talks through changing water quality, shifting biodiversity, coral bleaching, pollution, invasive species, and the climate stress. The question is simple, but it's not easy. Are we actually listening? And if we do we know how to respond in time? This matters more than ever. Demand for aquatic food keeps rising. So does the pressure on our rivers, lakes, coastlines, and our reefs. This isn't some distant future problem. It is already showing up in our fish stocks, in our aquaculture yields, in coastal livelihoods. Aquatic environment management sits right in that crossroads of ecology, economics, and the community well being. It is about understanding not just how ecosystem works, but how industry and policy can work with them instead of against them. This theme is pretty personal to me, as a lot of my work has been about learning to read these exact signals, studying how the corals respond to heat and nutrient stress, assessing species in coral reefs, doing field work on damaged reef. I have seen how much a reef or a fish population can tell if you know where to look. And I've seen how much value there is in turning this understanding into real decisions on the ground. Today, we have multiple speakers joining us, each bringing a different piece in this picture, from aquaculture system to field conservation to environmental science to aquatic ecotoxicology. Let's welcome them. I now welcome Akansha uh, to introduce the speaker.
Thank you so much, Coco. So, our next speaker is Dr. Kedarnath Mohanta, Principal Scientist, Head, and Joint Director of Fish Nutrition, Biochemistry, and Physiology Division in India. His research spans the nutrition requirements of freshwater fish, the development of feeding strategies for tropical food fish, and non conventional feed resources. With a monumental academic footprint, he has contributed 298 research and technical publications and generated over 90 plus seminars presentation globally. He brings over 30 years of elite scientific research, national policy formulations, and extensive institutional publishing perspective to this discussion. Please join me in welcoming Dr. Mohanta.
Let me introduce myself. Actually, myself, Dr. K N Mohanta. Actually, I am the head of this Nutrition, Biochemistry, and Physiology Division of ICR CIFE Mumbai. Many of you may not be knowing ICR CIFE Mumbai. This is a higher education actually institution. Mainly, actually, we deal with the masters and PhD in 11 discipline, and this is the only actually educational university in the fisheries for India, and throughout the actually from the across the India, from different fisheries college, they come for their masters and PhD degree. And generally we take the student through NTA exam, that is a national level competitive exam, and we take the 11 students from 11 disciplines. So as I am, and we have 6 division. Out of that, one division actually I am heading, that is fish nutrition, biochemistry, and physiology division. And today my talk will be regarding sustainable aquafeeds and feeding practices for enhancing fish production. So, mm, so uh, actually, India, I think maybe actually scientific fish culture we have started in 1975. Though actually induced two technology has brought blue revolution to India. One of the technology is the induced breeding, which we have achieved in 1957. And then in culture, and after the induced breeding, earlier actually we depend upon the actually wild seed stock. So when we actually successfully bred, particularly calves, so we are now actually self-sufficient in seed production. Then regarding the culture technology, scientific culture technology we started in 1975 with one project, All India actually coordinated project, that is All India coordinated project in composite fish farming. So these are the actually two events. Events means these are the two actually, I say, events that brought the blue revolution in India. And this is the, now we are standing now. If you see India in 1975, our production was hardly 0.75 million metric ton. Now we have almost achieved 20 million metric ton, and we are the second largest fish producer. Our growth rate is more than 8% now. Average aquaculture productivity is around 5 ton per hectare now. And if you see the actually investment in the last 5 years, investment was actually very encouraging. It is, if you see the actually, it is almost 50,000 crore government of India has actually allotted for fisheries development, particularly in development and research also. And budget allocation for this year itself is very encouraging. If you see in 2026, actually it is almost 2,700 crore government has given. And fisheries export, we are exporting to the 130 countries. This figure again changed. Now actually recent our export value is 73,000 crores, and we are actually lively opportunity we are providing to almost actually 3 crore population. So our figures are very encouraging. We should be proud of our actually growth in fisheries sector. But however, we should not be complacent with our growth. Actually, still, if you see the gap, first and second, we are called second, but we are called actually, this is only actually namesake second. If you see the Chinese figure and our figure, Chinese are producing 5 times more than us, India, particularly in aquaculture sector. Okay, then in aquaculture, if you see what is the modern day of aquaculture, before I say about my subject, let me tell actually now we say smart aquaculture, smart feed. First, actually what is the modern day aquaculture. It is nothing but if you see earlier, you used to see when I was studying 40 years back fisheries, that time definition of aquaculture is nothing but culture of aquatic organism in confinement with a little bit scientific inputs, maybe little bit technology intervention we are doing. But now things are totally changed. If you see the modern definition of aquaculture is nothing but nitrogen input and nitrogen output. And this is up to the earthen pond culture. In the earthen pond, what we do, 90% of our production is coming from the fertilized earthen pond. So this is the definition up to now. But now we are taking lot of new system, new actually species like RS, biofloc, aquaponics, raceway, cage culturism. So here, if you see the definition again, little bit will be changing. It will be like energy input and energy output. So what is required? We always say sustainable aquaculture, eco-friendly aquaculture. So to sustain the aquaculture, what we required is minimum nitrogen input and maximum nitrogen output, or you may say minimum energy input and maximum energy output. So this is the actually we want now. Then transformation, if you see in the aquaculture, as I told you, 1975 it started. So that time it was a sustenance aquaculture. Now it is sustainable and eco-friendly aquaculture. That time actually we are now also we give lot of emphasis on production. Now actually from quantity means production increase to we are going for the quality and safety. We have to produce some premium products. they have maximum middle class population, they can afford a good product. So definitely from quantity, they are shifting to the quality and safety. And again, from species diversification, we are actually bringing new system, as I already told, RS, biofloc, aquaponics, IPRS, cage culture, pen culture. So from species diversification, we are now actually switching over to the system diversification. Earlier, if you see, I am also from agricultural background family. I used to write when my father's occupation, they ask in the actually form, any form, whenever we are doing for educational purpose, we are using, I used to write occupation, my father's occupation, as agriculture. Now, actually, if you see the aquaculture scenario, it is not like occupation or vocation, it is business, trade, income, and employment. Okay, now not only actually our farmers are doing, now IIT graduates, IIM graduates, graduates from elite institutes are venturing to the fisheries and aquaculture. But what we remember is unlike any other agricultural crops, okay, like suppose you take horticultural crops, or maybe you take like pulses, it is a bit different. In case of fisheries, value chain in fisheries is more complex and it is challenging. But whenever actually challenge is more in any agricultural crops, then there is more opportunity. So when that's why it all when it is more challenging, then it also create more business, livelihood, and employment opportunity. Okay, then to start with aquaculture, when we say aquaculture, we start with seed. Not only actually our aquaculture, any farming system you take, even in agriculture also, it started with actually seed. But from seed, we are now shifting to the quality seed. If you see the agriculture and animal science, they have different type of seed: nuclear seed, breeder seed, foundation seed, certified seed. These are the actually new things actually they are introduced, already introduced. But what is the difference between these four type of seed? Breeder seed, they are produced from nuclear seed. Foundation seed, they are the progeny of breeder seed. And certified seed, they are actually produced from the foundation seed. And who is producing? Breeder seed is always produced by a research institute or the plant breeders or animal breeders. Or our case, mainly our breeding scientists. Then we actually foundation seed, they actually from research institutes, it is going to the National Seed Corporation, State Seed Corporation, and from foundation seed actually it is produced by certified seeds are produced. Again, state and national seed corporation only they produce. But what is the thing actually? You see the purity level 99 to 100%. Okay, but our fish so far this concept is not come. If you see the purpose also different purpose actually breeder seed mainly actually we produce to produce the foundation seed. Foundation seed we produce to produce the certified seed, and certified seed only we have to give the farmer. But so far we are not giving any certified. If you give suppose feed, everybody says 60 to 70% of your operational cost is feed. But feed will not do anything if you actually use quality feed, whatever quality you give. If your seed quality is not good, we say actually in Hindi, if you आप feed का हिसाब से आप अमृत भी खिला दो, if you feed them nectar in the form of feed also, if your seed quality is not good, finally you will not get good harvest. So it is very nice that it was actually maybe 10 years effort government of India and the research institute they have done, and finally they brought the guidelines on hatchery accreditation and seed certification of freshwater kingfishers and shellfishes. It was published very recently in 2025 by the Ministry of Fisheries, Animal Husbandry and Dairy Government of India. Every fish farmer, every actually aquaculturist, every researcher, you must read this document. I appeal all the people, those who are involved in fisheries, must read this document. My next, now actually out of once I told about little bit about the seed, quality seed. Let me tell my real subject. It is aqua feed or fish feed. You know, actually, we are also now transforming. You see the actually how many types of feed for different purposes in aquaculture we are using. Initially, we started with sustainable aquafield. Our purpose was to increase the production and productivity. Then we actually are going for the functional feed because we got enough production now. Every year we are adding 1 million metric ton production. If you add still more, it will be problem because fish is the only meat or only actually product, animal product, which is actually available in a stable price. Its price is not increasing. Maybe 10 years back, you see, farm-made price of fish was 100, now also 110. Whereas in case of mutton, it might have increased 3 to 4 times. So this is the scenario. So actually, it is poor man's food. It is actually super food in terms of animal protein. So we are producing lot of actually fish now. So the sustainable aquafeed has played a very major role to increase the production. Now actually from production, as I already told, from quantity we are actually moving to quality. So functional feed are very important. And if you see the India, our climates are actually very diverse. Starting from actually Jammu Kashmir, if you go to the your Tamil Nadu, across the state, there you will get actually in case of Jammu Kashmir, maybe 3 to 4 months we cannot culture the fish due to cold. Whereas in Tamil Nadu, Odisha, West Bengal, due to very hot in the summer, again we are facing problem that time. Actually, stress is the major factor. Fish for not for good growth. So we are now developing climate smart feed. CIAP has done a lot of work. Not only CIAP, other institutes are also coming. We are formulating the climate smart feed to mitigate the stress, particularly during summer and winter season, 3 to 4 months what we get in the India in different parts of the country. Then we are actually going to the carbon neutral feed. Every year now actually is a concern, actually environment concern. And you know, actually I'll tell you in later part of my slide that actually what is the actually carbon neutral feed and why is so important. Then we are actually going for low protein and high energy feed to reduce the production cost, low or zero pollution feed to maintain the water quality in the system, feed for polyculture because now we are culturing 5, 6 pieces which are very much compatible. So we are giving a single feed. So we say polyculture feed, feed for high density fish culture. You know, actually different system already I told. Every system, different type of feed is required. We cannot use the same feed what we are using in the pond in a different system. Okay, like biofloc feed will be different than the aquaponics. Aquaponics feed will be different from the raceway. Raceway feed will be different than the catch culture, as I said. Okay, then organic feed. The government of India is now giving lot of importance to the natural farming and organic farming. So organic feed we have to produce, taking the organic inputs. Green feed produced by green leaves, farm-made feed for the marginal and small farmers. These are not very balanced feed, but it is okay because we are feeding. If you see in Indian context, only 15%, less than 15% of our farmers are using regular feed. So we have to increase. Really, if you want to increase the actually fish production, definitely actually our feed-based aquaculture, what at present is 15%, it should reach up to 45% or 50%. You know, actually now our production level is 20 million metric ton fish production. But government of India has given us the target by 2047, it should be 40 million ton. Fish production generally comes either by horizontal expansion or vertical expansion. There is a very limited scope for the horizontal expansion, so we have to do vertical expansion. Vertical expansion means, as I told, high density fish culture we have to do. When you do the high density fish culture, all the culture system are completely feed based aquaculture. So definitely our whatever we are using the feed at present, it has to increase to at least 3 times to meet the target of fish production. Then we are actually medicated feed to control the disease, region-based feed to reduce the production cost and carbon footprint. Then feed and feeding behavior for large water body. We have so many large water body and they are underutilized. But you cannot use the regular feed what you are using in the pond feed. So that is what we are actually there. It is different. Then national feed standard we are developing. I am also the national member for FSSI, BIS. So we are developing the feed standard already for actually animal. It is there for fisheries also. We have developed. You must go to the BIS website and you can find it out. Then actually protocols, feeding protocols. Okay, you have prepared a very wonderful feed, but you don't know how to feed the fish. You know, actually we feed the fish based on their body weight and in different actually sizes, different percentage of body weight we feed. So we have to know the feeding rate, feeding frequency, feeding zone, then feeding rate, everything actually you have to know. Feeding devices, then only actually you'll get good production with minimum input. Then feed quality assurance, physical, chemical, and biological quality is very important. So these are the basic knowledge you should have to get. Then regarding feed, as I told, 60 to 70% of the operational cost is due to feed alone. So we have to produce the nutrition and the balanced feed. We have to actually formulate based on the nutrient requirement of the fish. Then what is the actually quality feed? These are the parameters you know very well. We actually use the feed for better growth, survival, improving immunity and health, developing the healthy broodstock, improving the breeding performance, producing the quality against seed, settling the larval cycle and growth culture. Many things are there. And finally, actually, if you see to produce a quality fish, okay, and also to improve the storage life of also fish, feed is playing a major role. And in case of ornamental fish, as you know, actually pigmentation and coloration is very important. So we give a certain coloration in the feed, not synthetic coloration. We actually change the ingredients where actually more beta carotene are there, so we get the actually good color. Finally, we increase the actually fish production per unit volume, and also if you give a good feed, your soil and water quality will be good, and finally you will have a sustainable aquaculture practice. These are the feed, starter feed, grower feed, broodstock feed. We are now giving more emphasis on the finisher feed and maintenance feed. Every feed is having different purpose and it is used in the different life stages of the fish. All you know. So use of feed, if you see in a standard culture practice, if you see actually feed, grow out feed are used 80% total feed. Suppose 100-ton feed requirement is there in a farm. So 80% actually feed they want is grow out feed, then followed by broodstock feed and then larval feed. So in a culture system, as I told you, seed is the primary input or most fundamental unit input, and feed is the most costly and critical input. We give actually question to the student also, which is most actually primary and fundamental input. It is seed, which is most costly and critical input is feed. Okay. So to produce, and you know actually to start with culture, we want quality seed. For getting the quality seed, two diets are required. One is actually broodstock diet, and second is larval or nursery diet. So these are very important. If you don't give a quality broodstock and larval diet, we are getting on our actually production. If you see in case of India, from starting of the actually seed means from spawn to the stockable size fingerling, we get only 20 to 30% survival rate. Rest are dying. Nowhere in the world that much mortality is there during seed rearing. So definitely broodstock and larval nutrition plays a very greater role for the actual fish production. These are the nutrients, all you know, all professionals are there. So I need not say protein, carbohydrate and lipid are the actually major nutrients, and minor nutrients, mineral and vitamin, all are very important. Every nutrient is different function. If you are not giving in optimum amount, fish will never grow that much, or maybe it will be immune to disease or something actually will happen. So the, all nutrients are actually in optimum level we have to give. But what we see, the people are actually maintaining the protein, the carbohydrate, but they forget to maintain the P by E ratio, which is very important. You insist all the feed company to write the P by E ratio, not protein and energy. P by E ratio, if it is not there between this range, then definitely your fish is not growing. I am telling about this for the omnivorous fish, like what we do, carp, pangas and tilapia. Our 90% fish production is from omnivorous fish. These three species, three group of species. One is carp, then tilapia and pangas. There we maintain P by E ratio this range. If it is your feed is containing this is the range P by E ratio, it is good. For production of sustainable aquafeed, these are the things, basic thing we required: knowledge on nutrient requirement, feeding habit and behavior of the fish, fish feed ingredients available in the country, not only available, quantity and time, area where it is available. Then we have to innovate the new ingredients and novel ingredients, because what happened till now, from actually 90s, we have started actually feed-based aquaculture, but still we depend only 5 to 6 ingredients for our culture for preparing the feed. Any type of actually feed you prepare, maximum we are using 10 to 12 ingredients, but that same ingredients are being utilized by animal and poultry industry. So there is a lot of competition. and all the ingredients, all they are the agricultural byproducts. Since our agriculture actually production is not increasing substantially, we are also not getting the substantial increase of our feed ingredients. So for the fish feed. So this is actually everybody's challenge. Everybody should attempt to bring new ingredients. Researcher, feed mill owners, maybe aquaculturist, everybody. Then proximate composition of feed ingredients, these are the knowledge you required for developing a quality feed. I am telling. Permissible level of each ingredient. So every ingredient is having maximum how much actually percentage you can use. Scientist has given the figure. You must know that shelf life of each ingredient. Each ingredient is having different shelf life. You must know. Otherwise, you will purchase whenever it is cheap. If you are purchasing and you don't know about the shelf life of that ingredient, they are actually prone to the fungus. Very very well. So finally, actually, it will be wasted, and you will be losing the money. Then processing method of each ingredient is different. This feed production technology is also different. Then quality assurance of the feed, physical, chemical, and biological quality. What is the optimum level? You must know and you try to maintain. Then our approach to produce sustainable feed, follow the national feed standard and feeding protocols. BIS has developed, Bureau of Indian Standards. Follow the good aquaculture practices developed by BIS, NFDB, ICR Institute. Follow the SOP for fish feed production. Government of India developed. We have also developed. CIFE also developed, and we have given to the many state government. Use the feed formulation app for development of feed formulation. We have developed a feed formulation app sitting in your room. Also you can develop for any species, any stages you can develop sitting in your house. We have used the artificial intelligence and machine learning. So use of the feed formulation developed by ICR Institute, SAU, or the research organization. You people are not knowing, but recently we have compiled, we made a document. It was actually told by our Dr. Ayappan sir, who was earlier DG and very famous scientist. He is no more now. So we have actually, I only combined all the ICR Institute, how many feeds are there. So there are 8 fishery institute, and they have developed about 30 feeds during last 5 years, 5 to 6 years, and all the feeds are commercialized to the different companies. You should actually use this formulation, or from this company you purchase the feed. They are the balanced feed, and they definitely their performance will be better. Then choice and selection of ingredients is there. Actually, we have given in the BIS also document what are the different ingredients we have to use for different fishes. Okay, same fish, maybe ingredients are different for different fish. Sorry, for different fish, ingredient choices are different, because suppose your fish is herbivore. So these are the approaches you should know. Then actually this is the CIAFT Optima. From the 6th thing I have given, these are the important features of the Optima. This is actually feed optimization. These are the things you required already. I told. Then actually these are the different actually system specific feed we are actually taking. These are the RS, aquaponics. Already I told people those who are knowing, they must know. But so far we have developed the feed only for 10 to 12 species. 50 species culture actually ICR is now introducing. So we have to do lot of work for developing the fish feed for 50 species. Okay, then this is the main problem when we go for the feed-based aquaculture. Carbon footprint is the main problem. I have given the positive agents, positive, what are the causes of the carbon footprint, I have given. I will not tell in detail because time is short. And then what is more important actually, what is the mitigation strategy? These are the 10 strategy we are following to mitigate the carbon footprint. This is the water footprint. If at all there is actually third world war, this will be due to the water, because only 3% fresh water is available in the world, and this 3% is used by animal, by fish, and also by the plants. So definitely water footprint in feed-based aquaculture also actually it is increasing. We have to do what these are the causative agents, these are the mitigation measures. Okay, this energy footprint, everything now actually government of India is doing it how to reduce the energy footprint. So in aquaculture also energy footprint is very high. These are the actually positive agent. This is the mitigation strategy. I am just touching the point, and we bringing more novel ingredients. As you know, these are the novel ingredients we are bringing: insect protein, SCP, marine algae. Lot of work we have to do. Okay, we have not done. These are the actually, these are the 6 species we have developed. These are the high yielding species. They are called genetically improved. We have not done any work with these species. we don't have any feed for this. Lot of work we have put. Okay, the climate resilient feed already I told, winter feed and summer feed very important. We have done lot of work, so we have commercialized. We can use this. Then actually feed standard already I told. Actually inland saline area is coming in a very big way. We have to culture these inland fish in this inland saline area. Their feed is totally different. We are doing now Benami culture. It is giving very good result. 6 tons per hectare we are getting, but their feed is different. We have already developed and commercialized. Ornamental fish feed very important. It is one of the sector. It is called flipping joint. It is coming very actually aggressively now, and we have to develop the ornamental fish feed. Quality and safety of the feed, definitely it is important. No research has been done. Okay, so it is required. Then actually aqua feed production cluster is required in the country. So actually in one place only, government of India has developed 35 fisheries cluster, but there is no cluster for aqua feed production. So aqua feed production cluster also in one area, maybe 100 feed mill is there, should be there, and whoever is actually require feed going there and taking this feed is will be easy. Okay, so this is very, then human resource development for every purpose for feed it is required, you know very well. We are actually training the people. Okay, these are the
Excuse
actually
me, sir.
yeah. So this is the
Means
actually this is the thing actually, madam. I told you. So you could have told me how much the time, but anyway, I'm not told. But this is the thing I want to tell you. We are developing lot of literature. You go through our website. You go through our actually institute publication. Where I also put in the research gate all new publication. I put in the research gate. You go to the K N Mohanta's CIAP. All the information also, particularly feed nutrition. Our division is the best division in the country. So actually we publish lot of research paper, then technical articles you go through and you can get all the information. Thank you very much. Thank you very much for telling me. And
thank you so much, sir. Thank you so much. There was so many information. I'm so sorry. You should have
yeah,
informed the time before.
yes,
But
yes,
definitely, if anybody have any doubts, can they reach you through your email?
yes, please.
Yes. Next speaker, Dr. Adhavan Devendran, who leads coastal and marine conservation at the HCL Foundation. He has spent years on field on marine biodiversity assessment, coral translocation and monitoring, sea turtle monitoring, and fisheries resource management. He's worked on the coral restoration project under the World Bank funded integrated coastal zone management program in the Gulf of Kutch Marine National Park. I also want to say a special thanks to Dr. Devendran. He is joining us today in between active fieldwork on such a short window of time. He won't be able to stay through our panel discussion later, but we are really grateful that he made the effort to stay here and share his experience with us regardless. The floor is yours, sir.
Hi, good afternoon. Thank you for the introduction, Kodai, and thank you for the opportunity. So I need to share my screen now. Share. Okay. Give me some time. So you can see my screen?
Yes, sir. We can.
Okay. My slide is in. You can see my slides, right?
Yes, sir.
Okay. So it is in presentation mode. Thank you. Okay, thank you, team. Thank you for this opportunity, and I really appreciate your effort towards this. And like previous speaker also was giving a lot of information on the aquaculture. It was nice. And now I'm going to talk about the coastal and marine ecosystem, current status and challenges, and the conservation initiative, what we can do, and what we are doing, and being a students or being researchers, what you can do from your point of view. So this is what I'm going to talk today. So first is like I want to say about this the high protected ecosystem in coastal marine is like we already know the estuary, mangroves, coral, salt marsh, seagrass meadow. So all these ecosystem they have a specific role to play in the ecosystem services as well as like the socioeconomic status of the coastal communities. So we can see nearly how this ecosystem services we are getting from this coastal marine, that is coastal protection, fisheries, livelihood, tourism, biomass, and they also acting as a feeding and spawning ground for many commercially important fishes, and they are also maintaining the water quality and provide habitat for marine life. So these ecosystem are under threat. So we know what are the threats and how who are the reason for the threats. So we are the reason for the threats, and and we also talking about mitigation measures and conservation, but still on the other hand we are continuously doing this pollution and other threatening factors for this ecosystem. So for first is pollution and climate change and overfishing, unsustainable practice. These are the threats to the coastal ecosystem. Uh, yeah. Okay. So now we all know that India's one of fishing is one of the major activity happening in along the Indian coast. So nearly 174,000 fishing gears are actively involved in fishing activity in India, and nearly there are a lot of fishing gears also getting lost, and this and that is caused ghost nets and marine debris. That is also a major part of this marine pollution. So, marine debris, again, we all know marine debris, again, it's plastics and other waste product what we throw into the sea. This is not only into the sea, even the I mean, the people from the landlocked area, when they are disposing, there's no proper management of the waste. This waste also carried by the river runoff and finally ending up in the coastal and marine ecosystem. So, each and every one of us, directly or indirectly, are reason for this marine pollution. So we also should understand, coastal marine ecosystem produce 5 times or 7 times more oxygen than the terrestrial ecosystem. So we also protecting this terrestrial ecosystem. At the other hand, we also should protect this coastal marine ecosystem. So for many reasons, for people from landlocked areas should not think like I'm not directly involved in marine pollution. We are involved, and they should not think like I am no way using marine product. We are using. The salt is also coming from marine ecosystem, and a lot of medicines or a lot of food that are taken by the people from the landlocked areas also coming from marine ecosystem. So somehow we are related to marine ecosystem. So plastic is one of the major threat to the marine ecosystem. So what happening to the plastic? So when we are disposing the plastic material or plastic, 1 minute. Shall I turn off my camera if you don't mind, so that
No problem, sir.
yeah, okay. 1 minute. Yeah, okay. So these plastics, they are a major threat, as I said before. So how what we are doing is we are knowingly or unknowingly throwing this plastic into the sea, and this is affecting our marine ecosystem. And we are thinking it is affecting only marine ecosystem. This world is not only meant for a human being. This there are also other organisms living in this world. Only with those organisms we can live in this world. So we should understand only human cannot live in this ecosystem without other living organisms. So we also have to live with the other ecosystem, that is called ecosystem balance. So these plastics, there are different types of plastic are entering into the sea, and once a plastic is plastic paper or plastic bag or plastic cover, single use plastic, whatever, it is entering into the sea. That is broken into small pieces due to a lot of physical activity. And there are different types of plastic, that is macro, meso, and micro. So macroplastic is the large one, and the mesoplastic is a small one, the broken it is visible, still visible to the eye. And microplastic, it is not visible to the eyes. So, as I said before, these ecosystems mangrove, seagrass, and salt marsh, coral. So, what happens? You can imagine the ecosystem. You can imagine in your mind the ecosystem are lined up in a are lined up, aligned in a line, where you can imagine if the rain comes and the flood is coming from the land, and the flood water contains all sort of toxic substance, including plastic and chemicals or everything, whatever. So that is taken to the land, I mean from land to the marine ecosystem, passing through these ecosystems. So first comes salt marshes, then comes mangrove, then comes mud flat, or then sea grasses. So these ecosystems, they are acting as a filters. So the salt marsh is also has a set of organisms that can break the complex substance into smaller, I mean, into a organic to simpler one, so that the organism can digest that and make into digestible fare where the plants can absorb that readily. And again, if you can imagine if these substances like a chemical or debris or directly entering into the sea without any filtration, you can imagine like biofilters. Okay, biofilters, what we have different layers of sand or gravels or charcoal or cloth, something like that, we'll have biofilters. So these ecosystem also are acting as a biofilters. So when this contaminated water or polluted water entering into the sea, these ecosystems like salt marsh, mangroves, and seagrass bed and mudflat, they also acting as a filtering units. So what happened in the mangrove ecosystem, again we also have commercially important fishes and microorganisms and crabs. So their work is decomposing of dead and detritus matter, in mangrove again. This pollution will be filtered, and the floating sediments will be taken to this mud flat, and the baffling effect of the seagrass that will settle down the sediments, and the clear water will be going to the next ecosystem. So that's like a coral reef also can get a clear water, so that the fishes and other living organism can have this good thing. So imagine if any ecosystem in this pattern has destroyed, there will be a catastrophic effect in this marine ecosystem. So that will directly affect the changes in the other ecosystem, seagrass or coral reef. When coral reef is affected, then there will be a biogeocycle fallout, and there will be a disturbance in the carbon sequestration, and there will be a disturbance in the fisheries production, and again it will play the climate change will be in place. So this is how it is affected. And we also, this is a small example, but ocean is many things. Nature has its own style to reset. But if nature resets it's by itself, we also cannot survive in this. So we have to aid the nature to what to say to protect the nature for our living being. Okay, for our benefit. So how these plastics are entering into the food chain? So you can say the small plastics, when it is entering into the sea through human intervention or river runoff, then it is what happened, it will be broken into small pieces. And this these plastics are covered with microalgae. So in marine organisms, in any water body, if you put something, a thin slime layer will be formed over the substance that is called, that is covered by microalgae. So this microalgae, what happened, they produce dimethyl sulfide. So this dimethyl sulfide smells like a food. So these marine organisms, and they think, okay, this is a food, since the algae is producing dimethyl sulfide. So they'll think, okay, it is a food, and they'll be consumed by the next trophic level organisms like krill or small zooplankton, or fishes, shrimps, whatever. So again this plastic is entering to next level. And then again, when the birds is feeding on the krill or like a shrimp or small fishes, again the plastic will be entering into bird's body. And birds also directly feed on this plastic by because of the smell of the dimethyl sulfide. So in this pictures you can see a lot of plastic are discovered from the dead bird, shoreline bird. And again, a sea turtle they consume jellyfish, okay, sea jellies. So these sea jellies, sometimes they the when the plastic bags are inverted and going into the sea, they misunderstand this as sea jellies and they consume that, and it will get choked in their digestive system, and again that will be like a negative impact on their uh, life. So as I said before, how this plastic is entering, so like mostly the it is from river runoff. And when we are like mishandling the plastic, like there is no proper management of plastic, this plastic ecosystem is getting enter into the ecosystem. And sometimes the fishing net, a discarded fishing net, that is also like when fishermen like not handling the fishing gear properly, when it is not of use, they simply throw, like most of the fishermen, they simply throw that into the sea. And sometimes due to like bad weather condition, they had to leave the uh, this fishing nets, and this will cause this will keep on fishing for none. So that is called ghost fishing, and these nets are called ghost nets. So you can see the pictures, like all these pictures are taken from Indian coast, along the Indian coast. So first picture is from Gulf of Mannar region, Rameshwaram first, and the left is from Rameshwaram, and the last two pictures are from Andamans and Nicobar. And these are the status of like Indian coastline. We also have India's beautiful beach in Andamans, like Havelock Island, but still we also have I mean, world's dirtiest beach as well. This, who's the reason for this? We are the reason. So like we also have to understand, and we have to educate our friends and colleague, like whoever we are meeting, on this aspect. Like we should not pollute this ecosystem. Not only this ecosystem, like surround them, there should be a what to say, like positive management of this marine debris. I mean, normally the plastic handling. So as I said before, like how this fishing gears like ghost net is formed when fishermen going to the fishing, and the fishing net getting entangled into any rocks or something, and then they are left behind. So this fishing net are getting, I mean, again catching a lot of big fish, marine megafauna, including sea turtle or endangered species. And no one will be taken care, and there is no one to save these species, this animal when it is getting entangled. So when these species, they have to like lead their life, and they have to live, I mean, like die there itself for none, for no reasons. So how this microplastic is entering into the in our body? Again, as I said, like when these plastics are consumed by the fishes, and fishes consumed by human, and this human, like the plastic accumulation, bio accumulation will happen in our body. And nowadays the cancer, like cancer is the main reason. I mean, plastics are the main reason for the cancer inducing uh, property in our in our body. So like normally the human being, like female are affected. Like there are a lot of report on breast cancer. So plastic is again one of the main reason for this cancers, especially breast cancers and blood cancer. That is proven by some researchers. So we have to manage properly for our benefits, at least. Okay. And I also worked on seagrass. So I would like to take you through seagrass. Like what are seagrass? Seagrass is also called as like lungs of the sea. So it plays very very important role in maintaining the water quality and biogeocycle. And this will give what to say, like a proper food and breeding feeding ground for a lot of fishes, commercially important fishes, and fishes which are involved in maintaining the water quality and the biodiversity. It's about a lot of very good biodiversity. So sometimes, like people from research background, we also should understand what is seagrass and seaweeds. So like there are some misconception, right? Sometimes they used to misunderstand seagrass or seaweeds. So like first we should understand seagrass are the only flowering plant from the sea. There's no other flowering plant from the sea. And seaweeds are algae, they will not flower. And they also don't have roots, they have holdfast. But seagrass, they have rhizomes and root, so that they can grow underwater. and they also produce seeds. So these are the basic identification and differentiation between algae and seagrass, and how the seagrass works. So as I said before, the seagrass supports biodiversity and lot of organism, and that will reduce suspension of the sediments, and the seagrass blades they trap the sediments, and they also there will be also set of organism like benthic organisms which depend on seagrass ecosystem. They consume all the detritus and whatever filtered in the seagrass again. And fishes also, it's a hiding, feeding and breeding ground for many fishes. So like they also play very important role in stabilizing the sea for what to say, like biogeocycles also main a part of the seagrass, and they also sequester carbon in good amount. So, like as I said before, like seagrass ecosystem, they have they will bind the sediment, and due to the baffle effect of the seagrass, and they create a clear water, and they trap fine particle, take nutrients, and they play very important role in carbon sequestration. So from this slide, you can understand like how the difference between seagrass, meadows, and presence of seagrass and absence of seagrass. So you can see the water quality as well as and the biodiversity. So the most of the biodiversity, they prefer seagrass ecosystem as they are safe place, and they are providing shelter, food, and conducive ecosystem for the associated organism. When seagrass is absent, even the fishes also will not take that place, because the oxygen or level of the water will be very less, and the seagrass, they play very important role in sequestering the carbon. And next, if you see about the sediments, like sediments will be trapped by the seagrass, and again, when the absence of seagrass, the water quality will be very bad. It is not filtered, and again, it has very important role in playing the water quality as well. So, during this, as I said before, this ecosystem, salt marsh or seagrass or mangrove, they play a very important role in outwelling and wave damping and sediment trapping and nutrient fluxes and trophic cascade. So when the sediments are coming from land, so this ecosystem traps the sediments and pollutants, and during the wave action, these ecosystem protect the waves, and you can see the wave pattern in this in this, and so that the soil erosion can be protected. And when the sediment, again, the heavy pollution is from landlocked area, it is, I mean, land through the river runoff, it will be trapped by this ecosystem. Again, the clear water can be transported to the marine ecosystem, and when the high nutrients also are polluted in this ecosystem, it is not good for other ecosystem, associated ecosystem. So these are also trapped by this mangrove and salt marsh and seagrass. And again, cascade reaction, this one, like trophic level, like different organisms, they prefer this ecosystem. They depend on the food material which is trapped by this ecosystem. They consume that and they survive. So many fishes, they also migrate to this ecosystem for their feeding and breeding thing. Next is, as I said before, seagrass plays very important role in carbon sequestration and ozone acidification. So they trap carbon dioxide, they free living carbon dioxide, and they trap into the sediments, and they give very good, I mean, a good amount of oxygen. And if the seagrass is absent, the ocean acidification also increases because of carbonic acid which is released into the marine water, that will affect the calcareous substances, calcareous organisms. So how seagrass thrive in the coastal ecosystem? So they can withstand from temperature from 6 degree to 40 degree, and they have a strong foundation, and they have since they have anchoring roots ecosystem, they secure the plant, and they have flexible blade to which move along with the water, and they also nutrient sources for many associated organisms, and they also cannot grow without water, so at least tidal influence area they have to be there. And shallow, they are found in shallow water, and they also play important role in cleaning the water. And these are the places where we can see seagrass ecosystem. And in this seagrass ecosystem we also can see coral reef ecosystem also in the Gulf of Kutch and Lakshadweep. And coral reef and the seagrass, also the patches of seagrass we can see in the Maharashtra Malvan region, and sort of in Goa coast. But the good amount of seagrass and corals are seen in Kutch, Lakshadweep, and the Gulf of Manna, Park Bay, and Andaman Nicobar. And Chilka also we can see seagrass, not the coral one. So these are the ecosystem where we have a good amount of seagrass in India. So this table, I think, these are the differentiation of seagrass, the seagrass which is found in India. We have made a table to identification, so that maybe in future I can share this with you guys. Okay, what is the threat to the coastal ecosystem? As I said before, pollution. So all these things, all these photographs are taken from India. So the first photograph, what we see, that one is from Kasimedu, that is Roypuram Fishing Harbor. And the second is again you can see the Park Bay region, and the third one, the lady picking up uh, I don't know, like she's picking up shells for this making of calcium powder. Now it is banned, but before 10 years it was in practice in Gulf of Mannar region. Again, seagrass ecosystem have been the anchoring of the ship, boat, small boat also, they are affecting the seagrass ecosystem. And apart from that, illegal fishing activity and marine pollution, and again sewage disposal directly into the sea without treating, this also cause bad impact, impact on this marine ecosystem. Okay. Seagrass, how they reproduce. So, there are two types of reproduction happening in seagrass. That is asexual and sexual. That is the asexual one is when the rhizome detaches from the seagrass. It will go. It will wash away by the. Taken away by the current pattern, and it will be settled in a place and get established. And another one is again the viviparous. So what they are saying is fully grown seagrass from their mother, the rhizome, would be fragmented again and will go and set in some places. And this one, I think the slide. Okay. So they also reproduce by sexual reproduction. That is a male gamete and female gamete, pollen grains will be united. And again, that one we can see in this slide. And when it is these seeds are released, and due to the pollination, they are also land pollination happens uh, with the help of insects. And there are also, there are also small organisms that play a very important role in pollination of seagrasses as well. Associated shrimps, associated fishes, they also play a role in pollination. And directly it also pollination happens in the water waves and water current also. Once the pollination happens, the seagrass goes and settle in a place and get established. So male seagrass release pollen grain, which is the longest pollen grain in the world when compared to any plants. So this one. Okay. So we also did seagrass restoration work. I would like to share, as a part of my research work, we also did seagrass restoration in Gulf of Kutch region. So there are a lot of methodology available, developed by many scientists, and these are the methodology like plug method, peat pot method, staple method, and these are the method which is already available. But this all the method cannot be applied in any coast, any other coast, because they have developed for their coast. So it can be we can check whether this methodology is working in our coast or not, because if you see Gulf of Kutch, there are a lot of the sediments are due to industrial impact. We have a lot of sediments coming around, and we are the tidal amplitude is also high, and the current pattern is also high in Gulf of Kutch region. So definitely we have to modify the methodology, or we have to develop a site specific strategy. So these are the like what happened, like we wanted to develop site specific methodology for this Gulf of Kutch region. So first we studied the distribution of seagrass and selected the site for nursery development and restore the seagrass in the nursery. So these are the methodology what we did. But we have selected three spots like Mitapur, Narara, and Pirotan. What happened in the Narara region and Pirotan, like the seagrass, the current pattern was more, and the sedimentation rate is also high. So Mitapur region was selected because the again the current pattern and sedimentation is less, and we also saw like there are a lot of rocks under the water, and these rocks they play, I mean they also protected some sites from induced currents. So we also selected a place that, and the species also selected, like there are a lot of four different species are reported, and Halidol uninovis, Alophila ovalis were selected for our work. And like why we selected is like these seagrass are like seen seasonally. If we see the seagrass this in this season, and next year we may not see the seagrass, and moreover the seagrass are also preferred, mostly preferred by dugong and sea turtle. It's getting exploited. And we also developed a site selection, like due to high current, as I said in the previously, we have selected a reef ecosystem where the like massive rock was there, massive reef. So that protected the site from the induced current action, so that the nursery was not disturbed. Yeah, okay. So before that we also studied the temperature, pH, and conductivity and salinity, TDS, stability, and the chlorophyll of this water. This is periodically we have like 1 year, like this is part of our like other project, we also did this. And this also played a very important role. So the methodology was the methodology what we use is which is developed by Fonseca et al. And we have not directly used this methodology, since because I mean the site is like not conducive for this methodology. So we have modified this methodology, and this is the first time for the site specific strategy of the seagrass restoration what we did in the Gulf of Kutch region, because this place is like completely covered with sediments and current pattern.
Excuse me, sir.
Yes.
Can we please go a little faster? We still have two more speakers to
Yeah, okay, I'll
join.
do that. Yeah, I'll do that. Thank you
Thank
very
you.
much. So these are the methodology what we use. Like we use iron frame. In this iron frame, like we have planted the seagrass and under the water the 5 meter depth. And again, this was studied for 1 year. And after 1 year, the periodically we have studied the status of the seagrass. It was good and it was stabilized properly, and the result was positive. And yeah, that's all. And difficulties, we also have had difficulties, the poor visibility sometime, and non-conducive weather condition. And the fishermen also, like they used to take the iron frame when it was deployed. And thank you for the opportunity. Thank you for everyone. Thank you the organizing committee for this opportunity. Thank you very much.
Thank you, sir. Thank you so much. This whole topic is very interesting, and personally, it is one of my projects as well.
Okay,
Thank you so much. We know there's only a limited time today, and we are grateful that you carved out this window for us.
thank you very much.
If we have any doubts, can we reach you out through email or anything?
Yes, sure, definitely you can write to me.
Okay. Thank you, sir. Uh, we are going to our next speaker now. Excuse me. I would like to invite Shailesh Gurung, Assistant Professor of Aquaculture in Tribhuvan University's Institute of Agriculture and Animal Science, Nepal. His work covers aquaculture systems in development, including biofloc technology, fish feed, nutrition, and cage culture practices across Nepal. Before we begin, I would like to personally thank Sir. He was originally scheduled to speak in session 1, but couldn't make it due to circumstances beyond his control. We are really glad he's able to join us today instead, and we appreciate him making this time today. Sir, this session is yours.
Hello. Namaste. Namaste, everyone. Just wait. Hello, it is Seri.
Yes, sir.
Okay, can I proceed ahead?
Yes, sir.
Okay,
Definitely.
thank you everyone for listening me. Actually, thank you very much. First of all, to the Victor. Yeah, actually, he allowed me the time to present my small presentation. Yeah. Actually, yeah. The overall scenario is based on the next frontier lines of aquaculture, basically development and research aspects in Nepal. I'm Sailesh Gurung. I teach in Tirupati University in IES of Agriculture Department. Just I would like to go through some overview. You know very well, it is just between the India and Nepal. And total fish production is approx. It is 1,23,403 metric ton. You know very well, and and out of the total production, we will gain 83%, about 83% from aquaculture production. Yeah, we have uh, actually we have only 17% area, 18% area of total plain areas where most of the culture activities of fisheries go on there, and the rest of the areas are hilly and the mountainous region, you know very well, and we are trying to cope up with the different water facilities into a productive means that is led by the or targeted by the government in Nepal as well. And besides it, we have around 50,000 ponds and around 15,000 hectare of land is practiced with the pond aquaculture system here, which has generated around more than the 5 lakh 20,000 people in the employment opportunities directly or indirectly. This is the overall scenario of Nepal. You can see, in case of different farming system, how it operated in Nepal. We have very preliminary data. We have different practice farming practices are governing here in Nepal, like pond, you know very well, gold, swampy land, raceway, caves, basically, and somehow enclosure. This also the most of the portion is accommodated by the this kind of graph. You can see 91,448 metric ton is from pond aquaculture, and then after 1,242 44 metric ton is from raceway culture. Then after others are very nominal. We can see in the pie chart also we have a very huge amount of fisheries culture activities is going from pond-based aquaculture that has embarked a very huge amount. In case of biofloc, as I did, yeah, and continuing the research on the biofloc system and about the emergence of biofloc in Nepal. Basically, what I've seen from my teaching profession around 15 years onwards, what I found that uh, there is a who came first. technician came first, or the very promising farmers or intermediate farmers came in the sector of bioflora in Nepal? There is a dilemma. There is a questions always. Because some people, some very promising people or entrepreneurs, we can say that they went to the foreign countries like Indonesia and other countries, and they brought it here from there, this technology, by seeing or by knowing little technology. Yeah. And it is introduced this way, but the technical manpower production is very, very, very nominal. It is here, and besides it, uh, there is no very precise government support from government as well. Although farmers, promising farms entrepreneurs are installing it, but there is a whatever the craze seems. Among the people in installing biofloc technology here, that is initially it is very fascinating. It looks like a very fascinating, but later on, what it seems that due to the uh, technology disbalance, or our lack of technical manpower, it is slowly they are abandoning it here. That's why it is very inevitable in our country, basically in case of BFT technology, and it suited in our case also, because besides 17-18% of plain areas, there is a hill landlocked area, and based on the climate change patterns and climate adaptability, um, case of things, we can promote it, not only as employment, not only for the sake of availability of animal protein source, but also it can adapt if we can disseminate this kind of technology, or we can develop this kind of technology in hilly areas. But although it is not expanded so well in hilly areas, but there is more probability can be extended in that areas. That's why I'm also very focusing on biofloc technology research to my students, whether it is undergrads or master students. I'm doing it, and this is the figures I have visiting different areas. And in case of cultural species, dominance of cultural species, yeah, you know very well, most of the areas are very dominated by calves. It is well-known fact. Then after it is trout. In hill areas, besides plain areas, there is mountains and hills in Nepal, and trout is very much it is flourishing. But in case of production, we cannot go up. I think uh, I, I have seen that there might be fish nutrition and other strength and other kind of problems are there. But research is going on from the side of Nepal government, Nepal Agriculture Research Council. It is going on from the decades ago. But up to now, whatever the production we should have to achieve, that is not we have found in that point. And altogether, yeah, Nepal government is very newly they've introduced pangasis and tilapia as well, because pangas is also flourishing a little bit in the place condition. Yeah, this is the overall scenario dominance of different cultural species in case of Nepal. In case of major intervention, what government in Nepal, besides capacity building, because besides different kind of interactions, besides different kinds of somehow research and dissemination process, yeah, what Nepal government has done, it is it was introduced in the past, from past to now, it is introduced different instance of Chinese calf from China. In different time bound, we can see that from 2011 to 2012, yeah, with the FAO, with the technical cooperation program FAO with Nepal government, they have imported the pure and varieties, yeah, of brood stocks from China, with grass calf, silver calf, and brigade calf, and it is done to some extent a good a kind of periodic exchange of brooders for the good quality of fingerlings and productivity at the farmers level. level. And then after what happened in 2019-20, that it was established also by the government in the name of genetic improvement of calf brood stocks for quality fish feed production. They've imported, common calf and Chinese major calves as well. Yeah, this is the way in different time span they are carrying. They're carrying different kind of different high vigor of strain of Chinese calves and common calves. And in case of in case of in 2001, if we go back to the previous stage in 2001, Nepal Agriculture Research Council of Nepal government that has they introduced GIP strain of Nightingale first time in 2001 in Nepal, and then after our IES also introduced GIP strain from Bangladesh. For it is basically it is focused on the research and evaluation 2009. And then after I visited Bangladesh many times with we have a good collaboration with Wolfie Center, and in my different type of visits we visited Khulna and other places of Wolfie's led brood stock area, research area of Rahu, and we have talked about the possibility of transference of G3 raw brood stocks, and this is the photo you can see here. You can see here. This is the photo we have talked, we have visited, and this kind of, if this kind of strength of raw and other brood stock we can fetch here, then it will definitely boost our production in the coming days. And this is the photo Nepal government, I've already mentioned. FU in collaboration, FU Nepal government has successfully introduced pangasis, around 4,000 pangasis fingerlings, PIT tag, that is imported, and it is disseminated in the government farm and the private farm as well. But the outcome is not achieved up to now. Let's see what will happen. This is the major interventions. And then after recently in 2026 May, government has allocated around 1.27 million US dollar approximately. For basically it is for the preservation and restoration of Asla, that is very declined species. It is listed by the IUCN, that is by schizothorax, along with all other kind of endangered species, cold water species, basically, like Asla, Kotli, and Sahar, Tori species. It is basically, it is very multifaceted and very a kind of very objective verifiable project it is, and it will run from 2026 to 2029. It's 3 years project, and it is focused on the trout area, basically trout breeding area, and where plenty of trout, like not only trout, other sahars, kotli, asla, this kind of endangered species, which is very native to the cold water. Slowly it is vanishing. And to cope up with these kind of things, government has centralized or identified Tirsuli River, central area of Tirsuli River basin of Nuwakot district of Nepal. It is a good steps, I think, from government side in the preservation and the restoration of some kind of endangered native species. And it is also inevitable to restore in the plain water, like warm water species as well, as I think. In case of, so I will show you some kind of photos. I've not presented more lines, words. I'm going to see the native species identity crisis libido options. Most of the, if you go to the capital of the country by different vehicles,
Excuse me, sir.
you see.
Excuse me, sir. Can we please wrap this up a little quicker? We have one more speaker, and we are slightly short on time.
Okay. Okay. Okay, like native species identity, native species, how we can florize it, how the identity of fish with the high valued fish can be tossed down with the livelihood options of the people, aligning with the river basin of most of the hilly areas Nepal, and that there is a identity crisis as well. In one prospect, it is a livelihood options. Another area, it is identity crisis. It is declining day by day. There is I think there is a two-way a goal, yeah, how to store it. It is very important. And now it is you see the freshwater snail, or simply we get gogia. It is very highly demand, It is previously it is only center focus on the ethnic community, but it is food beyond the ethnic committee. Only previously it is discarded, but now it has made a trademark. It can be carried away from the restaurants and other things. It is a there is a very lot of possibilities there we can see here. And there is a different value-added products now. It is emerging in Nepal in case of fish and different value-added commodities. Like and in the case, what after COVID-19, yeah, in 2020, what we have seen a lot of migrant workers, they return. When they return, what we see that they besides they returning for job in the foreign countries, we found that they are now try to engage with like different vegetable or fishing activities. Yeah, this is the good changing mentality in the use. And fish, yeah. Now fish is not only the farming. Now it is emblemed in Nepal's context, a tradition, a culture, a source of income. It is linked with our societal benefits as well. And in case of this is not Maldives and this are not other things. It is actually it is a normal pond area it is, but it is later on it is transferred into villa. It is a good emblem of how farming practices can turn into a luxurious villa plus luxurious income source. It is provided more than 1,000 people in employment cases, and this is the research and development tie-up what we have done in the previous actors with different for foreign bilateral agencies like NOFIC, USAID projects, yeah, different things. This is the things, yeah, we have also done a research like institutional based research and development like demand feeder, how it operates, like biofloc and different things, not only inside the institute but also outside the farmers feed as well. Aquaculture fisheries totally as a stepfather and stepmom in case of Nepalese countries. Why it is so? Because stepmom, because we are dependent on the freshwater resources. We have no oceanic or brackish water or somehow other water resources. We are confined with the very few species. We have registered very few species, like 10 to 12 species. We have no very much choice. And in case of stepfather, yeah, we have fisheries. Fisheries actually it is on the downfall of the both ministry, agriculture and livestock. So sometime in the previous time it was with the agriculture. Now it is livestock and veterinary ministry. That it is just in the backdrop of the different ministry. It cannot survive very well. Yeah, this is the academic research we have done. Basically, fish nutrition. Yeah. In case of fish nutrition, we are basically doing on low cost ingredients of dietary supplement like probiotics, even biofloc, a little bit about fish microbiology, plus post-harvest. This kind of research we are going on in university level. Lacking part in academic research, what we have seen like bacteriology and virology, vaccine, molecular-based resources, although we have very limited, or we can say no external funding agencies. Yeah, these kind of things we have seen. Yeah, what future possibilities? Yeah, there should be a lot of collaboration with research activities like research, like medicinal aqua product companies as well. For the R&D with the university, should start MOU should be initiated among university research agencies and government sectors, plus other stakeholders as well. And this is the things, yeah, SARC should be take very further steps in the regional collaboration for the fishing.
Excuse me,
Yeah,
sir. We still have one more speaker and very little time.
yeah, thank you, thank you. It's all right, yeah. I wrap up there. It's okay.
Yeah.
Thank you.
Thank you so
Yeah,
much, sir. I apologize for the inconvenience.
yeah, it's all right.
And I now welcome our final speaker for this session, Dr. Tapas Paul, Assistant Professor in the Department of Aquatic Environment Management in the College of Fisheries, Bihar, Animal Science University. He did his undergraduate studies at the College of Fisheries, Lumumburka, and his postgraduate and PhD in CIFE Mumbai. His research focuses on aquatic environment management, ecotoxicology, and aquatic pollution. Thank you, Dr. Paul, for making time to be with us today. We really appreciate you bringing this research perspective into this conversation. This session is
Yeah. Good afternoon, ma'am. Am I audible
yours.
clearly? Am I audible
Yes,
clearly,
sir.
ma'am?
Yes,
Okay,
sir.
okay. Just a minute, I will share my screen. Ma'am, my slides are visible?
Yes, sir.
Okay, so ma'am, just I want to know how much time I have to finish it up.
You have 10 minutes, sir.
Okay, thank you. So, good afternoon, ladies and gentlemen. At the outset, I would like to thank the organizers, Women Fisheries Graduate Network Forum, to organize such a wonderful conference on Global Summit 2026 and giving me an opportunity to share my research areas in front of you. And I think it is a unique platform because never heard about such a platform which is dominated by women fisheries graduates. So, a big compliments from my side. Being a fisheries graduate, I want to compliment for taking up this such a nice initiative. So, and I can see also some of my students are also in the organizing committee. So, a big compliments to all of them. So, today I am here to present my research areas on ecotoxicity of emerging pollutants to aquatic organisms. So, basically, I am working in the field of aquatic environment management for the last 10 years and doing my master's, PhD, and even now after joining as assistant professor in College of Fisheries, Kishanganj. So I belong to the College of Fisheries Kishanganj, which is a constituent college of Bihar Animal Science University. And we are providing here the undergraduate, postgraduate, and PhD degree program in different branches related to fisheries science. So now I will be discussing mostly about the emerging pollutants. So as we know that our population is increasing day by day, which we have in 1974 we have a 4 billion population. Now in 2046 we are projected to have 9 billion population, and also 70% of our wastewater, which has been generated by different kinds of domestic as well as sewage products, are being untreated. So this is resulted that all these untreated waste waters are being directly being transferred into our aquatic ecosystem, and which is generally contributing that about 70% of water are being contaminated. And you know that United Nations Sustainable Development Goals, in that we have two goals like life below water, which is goal number 14, and clean water and sanitation, which is goal number 6. So in these two goals, we are focusing mainly on how we can produce or how we can maintain a proper optimum water quality and how we can prevent the aquatic organisms from being intoxicated by these emerging pollutants. So what are these emerging pollutants? These are defined as compounds which are not continuously being regulated, but they are being released into the aquatic environment and they are not being detected by our sewage treatment plants. So there are many kinds of such emerging pollutants, which includes your personal care products, flame retardants, human pharmaceuticals, veterinary pharmaceuticals, perfluorinated these compounds, water disinfection products, then disinfection, this water pesticides, manufactured nanomaterials, and industrial compounds. So these are all different sources of our emerging pollutants. Now coming to the types, we have several types of emerging pollutants. Basically, these emerging pollutants, this term is emerging because with the advancement of technology, we are now able to detect this kind of pollutants which are not being detected in the traditional sewage treatment plants. So we are able to detect with the advanced treatment technologies and advanced detection methodologies. So there are different types of emerging pollutants, which includes pharmaceutical drugs and personal care products, which includes endocrine disrupting chemicals, persistent organic pollutants, then PFAS, which is also a very recently it is being getting serious attention among the scientific community because it is found in non-stick cookware, firefighting foams, waterproof materials, and then it is coming into the aquatic system and causing different kinds of toxicity. We have microplastic, as you all know. My previous speaker also has talked about the microplastic pollution and how it is being affecting the aquatic organisms. We have industrial chemicals and antibiotic resistance bacteria and genes. So now coming to the priority pollutants. So basically we have n number of such emerging pollutants. If we go to the US EPA guidelines or OECD guidelines, we will get there are n number of such pollutants which are continuously being detected in aquatic environment, and they are causing the toxicity and potential harm to the aquatic ecosystem. But out of this, there are some priority organic pollutants. First one is like pharmaceutical and personal care products. So they are basically originated from the domestic waste, because in domestic we are using different kinds of pharmaceutical products as well as personal care products in our day-to-day life. So in that we are using like antibiotics, painkillers. We are very commonly we are using utilizing these painkillers like diclofenac, ibuprofen, and then we have hormones. So these are all the pharmaceutical and personal care products. Also, we have endocrine disrupting chemicals. It includes triclosan. This triclosan is a compound which is found in the toothpaste as well as deodorant. So I have worked on this particular compound since last 10 years during my master's, PhD, and even a project we have run under this triclosan. And we have benzophenone. It is found in the sunscreen products. Then we know about the bisphenol A. Bisphenol A is one of the major component of the microplastic, and it is causing a different kinds of toxicity to the aquatic organisms. We have phthalates, we have synthetic hormones. Synthetic hormones means 17-beta estradiol, progesterone are there. Then we have persistent organic pollutants, which include the polychlorinated biphenyls, dioxins. Dioxin basically we won't get it in our day-to-day life in our domestic or domestic products or any kind of personal care products. But however, when these parent products, like as I give example of triclosan, when this triclosan is going into the aquatic system, it is getting degraded after some period of time because it is subjected to photodegradation or microbial degradation. So then it is degrading and producing this particular compound, that is dioxin, which is a cancerous in nature. When it is coming into the aquatic system, and then from aquatic system through food chain it is coming into human, and human it is causing these cancerous compounds. So then we have microplastic, then heavy metals we have, which are also called as the conservative pollutants and pollutants of emerging concern, because these heavy metals, there are some areas of the country, if we see this particular Bihar belt, there is a serious contamination of groundwater heavy metals like arsenic, iron, lead. Then if you see the Gangetic plains, the entire Gangetic plains starting from Punjab, Haryana, Maharashtra, then Bihar, West Bengal. So this area is being heavily infested with the heavy metals, and also the northeastern region of the country. So these are the priority organic pollutants. So if anyone of the audience or if anyone want to work on this priority pollutants and their effect in aquatic organisms, they can choose any product from this, and they can go for the study. So now if we see their presence in the entire world, if we see in the global map, it is being present, it is omnipresent in entire globally, like it is from the different North America to South America to Asia, it is presence is there. But if you see the Indian scenario, there is a peculiar one interesting finding is that there are six such emerging pollutants are there, which are mostly detected in the Indian coastal states. Why coastal states are most being this detected? Because this is the fact that the marine environment is located adjacent to this coastal state, starting from the West Bengal to Gujarat. We have a long coastline of 8,129 kilometers, and in that, adjacent to that, there we have seas and oceans. So, and most of these compounds are being directly released into the ocean. So that's why we have got a higher detection limit in the marine states as compared to inland states. However, also there is one more reason is that the amount of study which has been done to detect these pollutants in the India was mostly focused on marine ecosystem, but the study on the freshwater inland ecosystem is very less till now. So if we see the emerging pollutants which are detected in Indian scenario, the first number is caffeine. Caffeine is a product which is found in the coffee. We take coffee, in that we found this caffeine. And then we have a carbamazepine. This is a pharmaceutical drug. We have a DDT, which is a pesticide. Then we have diclofenac, which is also this painkiller we are using. Then we have microplastic and triclosan. So these are the six major emerging pollutants detected in the Indian scenario. Now, how these pollutants are coming into the system? So basically, these pollutants, they are coming from the wastewater treatment So from there to detect them, so they are in surface water. After coming in surface water, they are going into the your maybe the sediment or might be in the river. It is causing toxicity to the fishes and after that to the humans. And further, my slide, that TCS, that compound triclosan which I worked, you see that compound has been detected in the environment and then finally it is degraded to produce there are n number of compounds like 2,4-dichlorophenol, 2D-dichlorodibenzoedioxin, which is a cancerous compound. So by the photodegradation, they are breaking down and forming the different daughter metabolites, which are also more toxic as compared to the parent compounds. So there are different technologies that developed to detect this type of emerging pollutants such as HPLC, GCMS, AAS. We have different n numbers of LCMS we have, so we can detect this kind of pollutants. Now, suppose these pollutants are present in the system. So we need to find some biomarkers. By the biomarkers by which we can detect or we can say that what is the level of toxicity this particular pollutant is doing to the fishes. So there are different biomarkers, like this is our study only, we have done it, like behavior alterations is there, hematological indices, like we all know the hematological profile. Then we have the cytotoxicity biomarker, which includes the oxidative stress enzymes and all. We have histopathological changes. We have which we find it through using common micronucleus. We have some standard test for immunotoxicity also, where we some enzymes are there like myeloperoxidase, phagocytic activity, lysozyme. These are used as a immunotoxic biomarker. We have some biomarker for gene expression and metabolic profiling also. So these are the different biomarkers which we can use to predict the toxicity of particular pollutant to the fishes. So now what are the endpoints we need to find out? Suppose if any of our researcher, because I found the most of the audience are researcher. So I am making the presentation in such a way that at least you can get a research idea from here. So suppose if we want to do a study on the toxicological endpoints in different aquatic organisms. Now, what are the two different approach we can go? First of all, we have to go for the acute study, acute toxicity. Based on that, we can go for the chronic study. Now, what are the different endpoints? In acute study, we can find out like EC50, LC50, which are very commonly used markers to detect your acute toxicity effect in the fishes for any pollutants. And based on the acute toxicity value, then we can go for the chronic assessment, which is a long-term study with a environment relevant concentration. We can give exposure. So these are the different report of this particular in fishes, the endpoints like EC50, LC50, and all, which is found by the different authors. So now we come to the different tests. So how we can analyze those tests to assess the biomarker, because last slide I told about the biomarkers, that different biomarkers are there by which we can find out that we can detect that how much the pollutant is toxic to the fishes. Now what are the different tests we will do to determine this biomarker? So first, like genotoxicity test, there are comet assay and micronucleus are there, which are very standard tests are there. Then we have endocrine disruptance test, where we will do the vitellogenin test. We have biomarker based test, in which for neurotoxicity we are doing the acetylcholinesterase. For oxidative stress we are doing the SOD, catalase, GST. These are the three potential used biomarkers. For metabolizing enzymes we are doing GOT, GPT, LDH, MDH. These are the different biomarkers are there which we can do the test. Then for this chronic test, we can also determine the NOEC and LOEC. We can also determine the bioconcentration factor. The bioconcentration factor means if the pollutant is getting inside the fish tissue or fish body, how much level it is getting deposited. So that we can find out the bioaccumulation test, and also algal inhibition test and mesocosms test. So coming to the removal technology, as you know, there are different removal technologies, because this is the major lacuna of Indian wastewater treatment plant at this situation also, that our population is too much higher and there is a rapid industrialization is going on. So the wastewater wastewater treatment plant which is present in our different cities are not that much potent to eliminate this kind of pollutants. So that's why there are advanced treatment technologies such as activated sludge system, membrane technology, phytoremediation, bioremediation. These technologies are found to remove these particular pollutants. So I will be discussing in detail about the triclosan, the work which we have done for the last couple of years. So basically this triclosan is detected from the...
Excuse me, sir.
Yeah,
I'm
please.
so sorry. We just have the last few minutes.
Yeah, I will finish within 5 minutes just.
Uh,
So this triclosan we are, as I told, it is being present in the different personal care products and coming into the surface water, and it is causing different toxicity. So based on that, we have done several studies. So this was the study where we have evaluated the triclosan in different riverine and marine ecosystem and found out the comparison between the occurrence between the marine as well as estuarine system. So this study, we have determined the different effects of different temperature. Suppose if temperature is higher, then how much the toxicity will be affecting into the aquatic system, in particular fishes. So that we have estimated through that. And then we have a study on this. We studied about effect of pH on the triclosan toxicity, that how much if the pH is changing in the aquatic system, how the triclosan toxicity is affecting in the commercially important fishes. Then this study we have done on the immunotoxicity. There we have studied about this toxic effect of triclosan on the immunosuppression in the Pangasius hypothalamus, which is a commercially important fish. And also we have done the challenge study to eat ADA. Then we have also done a study on the stability of triclosan, this particular compound, that how much it is stable in the aquatic system, that what is if we are increasing the temperature or decreasing the temperature, how the stability is getting affected. We have also studied on the toxicity of triclosan in the aquatic algae, because we know that algae is the primary producer. So lamina is one of the primary producer. So for that, we want to see the effect of this particular pollutant in the
Excuse me,
lamina.
sir. I'm so sorry. Excuse me, sir. I'm so sorry. The session will automatically close in 2 minutes.
Yeah, okay.
That's why.
Okay. So these are all different study. We can just, if you want, you can get back to me anytime. So my final message will be like a green and sustainable remediation strategy we should promote, and we should have advanced detection system, regulatory framework, and we should find out its impact on the aquatic biodiversity, and finally promote for the sustainable aquaculture and fisheries. So that's all. Thank you. If anyone have any doubt, you can ask.
Thank you so much, sir. That was a very insightful session. I apologize again for the lack of time. Uh, Guys, I am so sorry. The panel session is cancelled due to time restriction. If anybody have any questions, please reach out to us. We will definitely email our speakers and get the answers to you guys as soon as possible. And if you want to have the LinkedIn contacts or anything as well, you can email us or text us. We will definitely send you all the links. Thank you so much. The next session 6, will start in a few minutes. I hope you guys are ready for it with another set of amazing speakers. Thank you.